Welcome back to the build. Positioning these Mazda RX-7 Series 6 front hubs has not been without its difficulties. After I first screwed them to my build floor, some guy in YouTube land sent me a message saying, "Mate, you've got them upside down." "Thanks for the advice," I said. Swap them left to right and put them up this way. I was just about to start fabricating my wishbones to the hubs when my son James came over. "Dad," he said, "why have you got the hubs upside down?" "Because," I said, "a guru in cyberspace told me I had them up the wrong way." Now James races, builds and dismantles RX-7s, so he's a real expert on them. So I flipped the hubs back up for a second time, back to the way I first had them. Then I start working out the geometry of my ball joints, and I find that the Unos ball joint, which is designed as a bottom ball joint, won't work in my application as a top ball joint because of its geometry on full compression. However, the Toyota Camry bottom ball joint will work as a top ball joint. So for the third time, I flipped the hubs up the other way, but at least now I've got all my ball joints working. Will having the hub up the other way from the original Mazda design matter? Well, I'm sure there's more experts out there in cyberspace who will advise me on that, but this black duck's had enough dramas, and on that subject I just won't be listening.
Eat my shorts.
When you fit a ball joint into a factory suspension arm, it automatically fits at just the right angle as it was designed to do. But I'm bringing together 3 different brands of car parts into suspension arms that are being built from scratch. My challenge is to mount the top and bottom ball joints I'm using at the correct horizontal angle into the front wishbone. I've got to figure that angle out by myself, and my starting point is, where will this hub be on full compression compared to the chassis? I need 2 measurements to be able to figure that out. The first one comes from the minimum chassis ground clearance I want to have when the car is bottomed out. 10 centimetres from the ground to there. That's the minimum I want. The second key measurement my equation needs is the distance from my rally tyre tread to the centre of the wheel. 33 centimetres. If I subtract the first measurement from the second one, I have the height at which the centre of the hub needs to be off my build floor to position it relative to where it will be on the chassis at full suspension squash. 22 centimetres from the floor to the centre of the hub. Now when I fully compress the top ball joint, the mounting plates that I'm making are at the exact angle they need to be to go onto the wishbone arms to get the maximum suspension travel that this joint will provide. And I had to figure all that out by myself. In making the wishbones this way rather than using the conventional jig, it's important to note that I haven't just positioned this plate into which the lower ball joint mounts horizontally. I've put the hub where it needs to be for the correct track and line up with the back, and I've also put it as the square shows with about 1 degree of neg camber, which is the minimum that I'll run. I'll probably end up running about 3. So that's the hub at full deflection on the ball joint at 1 degree, which puts the plate at the particular angle that it needs to be, which is not quite horizontal. But now I can weld the wishbone arms on, knowing that the angle of the wishbone arm to the mounting plate is correct. Every hub has a swivel line between the bottom ball joint and the top ball joint. And on just about every car made, that angle is not at 90 degrees to the ground. If it was, you'd have no feel in the steering, and when you let go of the steering wheel, the wheels wouldn't centre. So what manufacturers do is they lean that top joint back, and that angle there is called caster. You'll see it at its most extreme on drag cars, where they really want the steering to self-centre, and so they'll have a huge amount. Most conventional cars, including this one, will have about 1 degree. So when I position this hub to make the top wishbone, to get it closer to where I want it to be, rather than it being upright like that, I need to lean it back a little bit, like that. So although I've got adjustment within all the joints on the suspension, it just makes more sense to me to fabricate as much as I can with the hub at the angles that I really want it to be at. Then I can fine tune it with all the adjustment. The point I was making about this plate not just being horizontal, but worked out at an exact angle through aligning all the suspension components, is much more obvious when you come to the top. You can see clearly that this isn't horizontal or anywhere near it, but it's at the correct angle to give maximum movement out of that joint. Now, if I have duplicated that 10-inch measurement of the height from that swivel point to that swivel point, and transferred it correctly to the chassis from the top mount to the bottom mount, these two arms should be parallel. And from what I can see, they are dead parallel. So it looks like I've got that right. Main members of the top and bottom front wishbones are all cut and ready to be tacked so that I can test the suspension travel. And I've left all the adjustment on the top so I can pull that right in if I want to. When I was planning to use these Mazda hubs up the way the factory uses them, with the steering link arm down here, this was about as far forward as I could get the rack and pinion. And you remember that I was having troubles with that being too close to the wheel to get enough linkage to be able to go to the wheel. But in putting the hubs up the other way to make my ball joints work, I've raised that arm right up, which means, given the angle of the chassis, that I can now, instead of mounting the steering in there, I can bring it right forward to here. So I might have had a bit of a win on the steering today, because it looks like I still might be able to use this Peugeot 205 rack. The joint angle there is not too severe, and the alignment of the ends of the rack with the joints still works, because the chassis width back here is made to the width of this rack. So all of this lines up, and the arms will line up. Obviously they'll need lengthening out to the suspension uprights, and it's going to be parallel that way. So fingers crossed, after I get the front suspension tacked, we might have ourselves an easy solution to the steering, which would be good.